Today we'll be talking about our Watershed Atlas tool. And this was by Fernando the River Riviera.
And Ryan, the Mountain Man Woods. We received our data from several sources. We got our 250 meter DEM from Yale, who documented DEMs really well. And our HUC shapefiles we got from datagateway.nrcs.usda.gov, and our Utah state boundary we got from the Utah GIS government site. And now we go to the map that we created, and this has several important features. We have two different data frames, and we also renamed several of the elements like about text and page, and the name. Elements like the compass and the scale bars weren't renamed. Then we also included the base maps from Esri, and the bottom one was georeferenced from a base map. Now, it's important that we have this as the active layer. As we open the Watershed script, on the right we have the title and descriptions, and we import the HUC shapefile as seen here. You just navigate to that. Then we find the DEM, which is generally the statewide, so that it's all covered and encompassed. And once again, you navigate to that, as shown here. And the raster value is a very important number that we'll talk about later, but it needs to be a number between 0 and 6,000, and it determines the number of drainage cells of the most upstream section. The number should be a whole number to work properly. And the author, you put your name. Next we will be going to HUC select, which is a blank polygon shapefile that needs to be hollow. As seen on the left, there is one HUC file on both the upper and lower layers, and this is just for aesthetics of the map. Now we have stream outputs, and we're selecting them and we're finding it, and we decided to put stream outputs in the temp just for variety's sake. And we need to determine the color of the stream before we run the tool. And same with the watershed output. If we want a green watershed, then we have to determine that before we start running the tool. And then you put the HUC name, which is the same name as the HUC shapefile, just without the dot shapefile. Now this is very important for referencing later on in the code. And now we run the code. And it's important to note that when it prints out the current statement, it prints out the FID number and the HUC name. Also, the name of the author is printed. And yeah. And as you can see, the layers update, but you can't see the watershed until after it's run the program. And there it is updating again, and the watershed is being printed to the PDF.
And so now we will look at the tool behind the code. So the purpose of the Utah Watershed Code is to create sub-watersheds within a HUC with the associated streams. And this code was created with the GNU General Public License. Now we will look at the main program of our code. So to start out our code, we import modules. We import the ArcPy, the operating system, and the time modules. Within the ArcPy module, we import the environment and the .sa import star. So from there, we decide to set the output coordinate system. Since we are working in Utah, we are using UTM Zone 12. and we overwrite this every time the code is run. We also save our project in the folder 594 project 1. For your code to work, you'll need to do the same. So now we will be looking at the scripting arguments, which, as you can see from before, we have the HUC8, the DEM, and so on and so forth, which is referenced here in the code with the HUC, the DEM, the raster. So the get parameter as text will get the code from there. Now we will look at the elements that we define. And for these elements, we decided to save them in a temporary folder attached to the 591 project 1, just so not to clutter up your project folder. And these are the different elements that we use in the project. So now we will look at how we create the PDF. So we decided to call the PDF Watershed Atlas of Utah. And this is because we are using the HUC of Utah. Now we will check if the PDF path even exists. To do that, we will use the operating system for PDF path, and if it is there, we will remove it. This way the code will run smoothly. After this, we need to create the PDF. To do so, we use PDF document create, and this will create the PDF. After which, we will map the document, or map the map to a variable, and the data frame to a variable as well. From here, we will use search cursor, which search cursor is used to pull variables from the shapefile HUC8. Now we will go into the loop. To start out our loop, we'll use myRow in myRows, and this is just using the HUC8 shapefile. So we will start out with myRow.name. This will be pulling the watershed name from the shapefile. We will also be pulling the FID number. The FID number will be saved as a string to be able to work with the code later on. After which, we will be changing the text elements, name, page, and about text as you saw in the map previously. To make sure that this works correctly and every time, we wrote a few elements of code, for example, watershed and element text. This is used to make sure that the name is rewritten so that it will work properly with our code. The next part of the if statement is used to paste the current elements onto the map. For example, with the about text, we insert the author, the time, and the projection. And so with the time, for example, we have that as the month, day, and the year as shown. And with the projection, it is projecting the current output system, which we named previously. We will also use the arcpy.refreshActiveView just to make sure that it shows on the map. The next bit of code is add message, and this is just to make sure that we know what's going on as the code is running. Next, we use the processes select layer by attribute management and zoom to selected features. And this is used to zoom to the current HUC that we are working on. The next process that we'll use is the select analysis tool, which is used to select the current shapefile. Next, we will use the extract by mask, the fill, the flow direction, and the flow accumulation as used in the model. The raster calculator function uses the raster value, which was shown before, which was between 0 and 6,000. As you can see here on the left, this is using the raster value of 50, which has a lot of streams and a lot of HUC watersheds. And on the right, we have a value of 5,000, which has some of the stream and some of the HUC watersheds. And so that gives you an opportunity to see what you want to do with that. Next, we will use the stream length and stream to feature tool. And as you can see, the stream to feature tool outputs the stream output, which is used in the map and which we described previously. Next, we will use the vertices to points, snap deploy points, and watershed. The raster to polygon tool was also output to the map as watershed output. Next, we use a for-j loop just to give ArcMap a little breathing room. After which we will finish the PDF by exporting our PDF map which we've created using the export to PDF tool. And then we will use .append pages, which will add all of the PDFs together into one complete package. We will then save and close the PDF and then reopen it again for the loop. Then, once we are out of the loop, we will save and close the PDF.
And now we are ending the 67 watersheds. And because the count started at 0, 66 is the last watershed. And the elapsed time is 12 minutes and 55 seconds. And we're going to minimize ArcMap and open up our project folder. And you can see the 66 watersheds individually in each PDF, and as well as the compiled atlas, which we will open. And you can see all the 67 pages, and each one having its individual HUC watershed.